Welcome back. In this lecture, we will discuss some aspects of battery layout that goes into the design specification of a battery pack. Before we move on, we want to clarify some terminologies. When we refer to a cell in the context of batteries, we are talking mostly about a particular battery chemistry uh, and the specification of that battery chemistry. When these cells are put together, only then we have a battery. And synonymously, we can refer to the battery as battery pack or just a pack. A subset of the cells that are housed together would be referred to as modules. Again, these terminologies will become clear in subsequent schematic. This refers to a particular cell which has its own voltage versus current characteristic. Many cells are put together in series. Why do we need to put together cells in series? Because the voltages add up. While we do that, the resistance also adds up. So just from simple notions of parallel and series resistance, we can compute the overall resistance of a battery pack. This refers to the battery pack. That would be given by M divided by N, M divided by N, times the internal resistance of a particular cell. When cells are connected in series, the resistance increases, they add up, and the voltage also adds up. However, when they're connected in these strings of cells are connected in parallel, the resistance decreases because there are many paths for current conduction, and overall there is an increase in capacity and current. So we're interested in the overall voltage that can be provided by a battery pack and overall current that can be supplied by a battery pack. So the overall voltage is M times voltage of an individual cell. Overall current depends upon then parallel pathways times the current from an individual cell. So this and this are the important design parameters in a battery layout. So in many cases, we also notice and assume that the battery is ohmically limited. What do we mean by that? The most significant loss in a battery is because of ohmic drop. That is, the resistance of the battery contributes to the major voltage loss. Therefore, the voltage that can be obtained from an individual cell is the open circuit voltage of an individual cell minus I cell times the internal resistance of the cell. So if you have the voltage that can be provided by a battery is M times this quantity. So the power that is supplied by the entire battery pack is I times V battery. So that would be Mn times this quantity. What is important to notice is that the power provided by a battery, when we say battery, it is synonymous with battery pack or a pack, is independent of how cells are connected. Okay, so given Mn, that determines the overall power. It doesn't matter how many cells are connected in series or how many cells are connected in parallel. The overall power is given by Mn times I cell. This is a feature of a particular cell. This is also a feature of a particular cell. So this provides the overall power. So this is an important thing to notice. The overall resistance is determined by how many, not only by R internal, that is the resistance inside a particular cell, but also is determined by the resistance contribution from the interconnects. There are wires that are connecting each of these cells, and there is wire connecting these regions of the battery pack. So the total resistance is given by R external plus this quantity. So this can be approximated as in the following manner. So there is a component that scales with M, and this refers to the resistance from this part. Okay, so there is this resistance of the wires times this quantity corresponds to R external. So here we are clarifying the meaning of a module. So this is a matter of optimization. So few cells are put together, for example, in a module. So this is 2s, 2p, means two cells are in series. There are two parallel pathways. So the wires, this wire might be different between the different from the nature of the wires that connect in between these cells, and the wires that connect in between the module is different. The resistance of these wires are different from the resistance of the wires that connect in between the cells within the module. So this refers to a module. This refers to the overall battery. So even if there are M cells in a battery pack that are in series, so if there are two cells within a module, there are M by 2 modules within the cell, within the battery pack. So in the next brief lecture, we will look at how do you scale the cells to obtain a particular capacity. That's going to be the topic of probably next two lectures. Thank you.